Hello students, welcome to all of you in SAM Alchemy classes. You know we have discussed prior to this segment about hydrocarbons and especially chemical properties of hydrocarbons where oxidation is completed. So oxidation may control oxidation in presence of insufficient oxygen and combustion. Under different catalysts, different products were obtained. Now next is aromatization. Second, aromatization. What is aromatization of alkane? Whenever alkane undergo very high temperature and pressure get aromatized and gives aromatic hydrocarbons. Aromatic hydrocarbons approx 500 to 600 degrees centigrade. In such a high temperature, alkane get aromatized and converts into aromatic hydrocarbons. It means straight chain with left and right aliphatic hydrocarbon alkane converts into cyclic compound, cyclic hydrocarbon. So this is a bridge reaction for conversion of aliphatic straight chain into cyclic aromatic hydrocarbons. Since here alkanes converts into aromatic compounds, especially benzene, the base compound, from 6 carbon containing alkane, so it's clear that minimum 6 carbon containing alkane is required to continue this reaction, because minimum 6 carbon containing compounds are called aromatic, and base of aromatic is benzene ring. In benzene ring, since minimum 6 carbons are present, so minimum 6 carbon containing alkane undergo aromatization. Prior to it, alkanes doesn't undergo in aromatization. Next thing, in aromatization, like normal hexane, 6 carbon containing alkane written in this way: CH3, CH2, 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 CH3. 1, 2, 3, 4, 5, 6. This is normal hexane, can be written in this way, like this. 1, 2, 3, 4, 5, 6. 6 carbon containing open chain normal hexane. These 2 hydrogens can be written in this way. Here 2 hydrogens like this. Here one hydrogen from each that are bonded with single bond can be written in this way. Now here elimination of hydrogen and elimination of here hydrogen. Under aromatization, just see 2 units eliminated from these carbons, so double bond appears here, CH, double bond CH. Next here single bond CH. One unit from adjacent carbon, so 1 pi bond get appear here, single bond was already present. Next 1 pi bond here, again from this one, here single bond is present. Now double bond is formed and the single bond is present. So double, single, double, single, double, or it can be written like this in cyclic form. This is benzene ring. This is benzene ring in alternate order double bond that are represented by resonance. So aromatization is a process carried out by alkanes under very high temperature and pressure, where alkanes converts into aromatic compounds. So it's a bridge reaction between straight chain aliphatic and cyclic aromatic. So in conversion, very significant reaction, you can directly goes from alkanes aliphatic saturated to directly into aromatic hydrocarbons. Next thing, here elimination of hydrogen takes place. Elimination of hydrogen, how many hydrogen? 3H2. 6 hydrogen eliminated, 4 to 6 to 8, 4H2. It is 4H2. Elimination of hydrogen takes place. Therefore, we can say aromatization is a category of dehydrogenation. This is also called as dehydrogenation of alkanes. Aromatization is a subcategory of dehydrogenation, where from saturated straight chain alkanes, hydrogens are eliminated, resulting formation of aromatic benzene ring. Next is, since we know minimum number of carbon must be 6 so that the base compound of aromatic benzene can be formed. If we increase the number of carbon like N-heptane, normal heptane, so normal heptane can be written like this: CH3, CH2, 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 CH3. 1, 2, 3, 4, 5, 6, 7. Again, elimination of hydrogen. Elimination of hydrogen under very high temperature and high pressure. Base benzene ring will be formed with 6 carbon, and next will be methyl. The rest 1 carbon will be in the form of methyl. So total CH, CH, CH. This is benzene ring and C. Number of carbon 7. 6 plus 1, 7. Number of hydrogens 3, 4, 5, 6, 7, 8. 8 hydrogen, and here in parent C7H16, because alkanes had general formula CnH2n plus 2, C7H16. How many are left? 8. So 4H2. Again, elimination of hydrogen takes place during aromatization. That's why it's a category of dehydrogenation, and the product formed will be toluene. Toluene is formed. Next, after aromatization, next is alkylation. Alkylation of alkanes. Alkanes का alkylation क्या है? Whenever alkane get add with alkene, unsaturated alkane get add with alkene, so it's called alkylation. This process is called alkylation. Increase in number of alkyl group attached and number of carbon chain increases, and final product formed will be alkane again. From lower members of alkanes, higher members of alkanes are obtained. Very significant reaction. In alkylation of alkanes, alkanes get add with alkenes, and alkane finally gets higher members of alkane because number of carbon increases. Like this is isobutyl. This is isobutyl reacts with this CH3 CH double bond CH2. इससे react होगी. Now CH2 comes to this carbon and hydrogen comes here, and this double converts into single, and finally the product obtained will be CH3 C, CH3 CH3 single bond C. यहाँ से CH2 अटैच हो जाएगा सिंगल बॉन्ड, और इससे हाइड्रोजन अटैच हो जाएगा CH2 सिंगल बॉन्ड CH3. This lower member of alkane converts into higher member of alkane, single bond. All are single bond. This is propene, alkene, and this is isobutane. This is isobutane, and the final product obtained will be from left to right 1, 2, 3, 4, 5. This is 2, 2 dimethyl. Longest carbon chain 5, pentane. Pentane, 2,2-dimethyl pentane is obtained. Alkylation is a process in which alkane get added with unsaturated hydrocarbon like alkene and results higher members of alkanes, and number of carbon chain increases in the compound. Next is substitution reactions of alkanes. Substitution reaction. In basic concepts, we have discussed about substitution reactions, especially in alkanes. Free radical substitution is carried out. Free radical substitution reactions are characteristic feature of alkanes saturated hydrocarbons. We have discussed this free radical mechanism in previous segments. Here we will discuss particularly in alkanes like CH4 reacts with chlorine, chlorination. This halogenation is chlorination. Chlorination in presence of sunlight. सनलाइट की प्रेजेंस में यहाँ पर फॉर्मेशन ऑफ CH3Cl with HCl. Alkane gives alkyl halide. But since reaction is carried out through free radical mechanism, that's why in successive order, one after one, all the hydrogens are eliminated by halogen and polyhalogen derivatives are obtained. Reactions remains continued and polyhalogen derivatives are obtained. Polyhalogen derivatives मिल जाते हैं कैसे? Like CH4 when reacts with chlorine in presence of sunlight, one after one hydrogen CH3Cl, then again substitution CH2Cl2, then again substitution CHCl3 and ultimately CCl4 along with HCl. A mixture of alkyl halide is obtained during halogenation of alkanes in presence of sunlight, especially chlorination of alkanes results a mixture of halogen derivatives, polyhalides, and reaction continued until all the hydrogens are displaced. So next is how this reaction happens. So just see about mechanism. This free radical substitution. This free radical substitution is carried out in three ways under three steps, and these three steps are: first, reaction initiation. Halogenation of alkane, especially chlorination of alkane, is carried out by free radical mechanism, free radical substitution, and is carried out in three steps, in which first is reaction initiation. How reaction get initiated? Here Cl2, chlorine, in presence of sunlight. This covalent bond, single bond, sharing of electrons. Now these shared electrons are distributed equally. Shared electrons are distributed equally between both the chlorine. So here chlorine free radical is obtained, and this is homolysis. And we know homolysis always results free radical formation. So in reaction initiation step in presence of sunlight under homolysis, free radicals are formed. These free radicals are odd electron containing species. It has odd electron containing species and are highly reactive in nature. These are highly reactive due to presence of odd electrons, because chlorine has 6 electrons in outermost, 7, in which 6 are these paired, lone pair, and one odd is present in chlorine. That's why this chlorine free radical is highly reactive in nature. Now after reaction initiation, in reaction initiation free radicals are formed. After reaction initiation, reaction propagation. Second, reaction propagation. In reaction initiation, only free radicals are formed that are attacking reagent for the substrate, and reaction remains continued in reaction propagation under multiple steps. Like here, alkane is methane. Now attack of chlorine free radical. In presence of chlorine free radical, homolysis again occurs in presence of sunlight. So shared electrons are received by both carbon and hydrogen. Again homolysis. This hydrogen free radical and this chlorine free radical, formation of HCl with elimination of methyl free radical. This methyl free radical is formed. This is methyl free radical and is highly reactive in nature, because here carbon has one odd electron in p subshell. Now in next, CH3 free radical reacts with chlorine. Homolysis again occurs. This chlorine free radical get attached with CH3 free radical, formation of CH3Cl, and again generation of chlorine free radical. Chlorine free radical generated. This chlorine free radical again reacts with this compound, and reaction continued in this way. In propagation, next step, CH3Cl with chlorine free radical. Now here hydrogen, we can note it like this. This attacks here and formation of CH2Cl2 with hydrogen free radical. Again hydrogen free radical eliminated. Reaction continued till CCl4 is obtained as a final product. यहाँ पर रिएक्शन होती रहेगी और ये जो Cl free radical है ये क्लोरीन के फॉर्म में here homolysis occurs. So this chlorine attacks here and this hydrogen takes its electron and elimination of hydrogen and chlorine free radical in the form of HCl. So CH2Cl2 is formed. So reaction continued, then CHCl3, then CCl4. So ultimately, since methane has 4 hydrogen, so all the 4 hydrogen one after one get eliminated, substituted by free radical chlorine, and all the in place of hydrogens, chlorine get attached. In place of hydrogen, chlorine get attached, and polyhalogen derivative is obtained like CHCl3, CCl4, CH2Cl2 and CH3Cl. Next is after reaction propagation. Third is reaction termination. Reaction termination where chlorine free radical with chlorine free radical, formation of Cl2. These free radicals combine to give the compound Cl2 and reaction terminated. Reaction get closed ultimately after substitution of all the hydrogen from alkanes. Now order of reactivity. Order of reactivity will be tertiary carbon hydrogen will be greater than secondary, greater than primary, decreasing order of reactivity. Decreasing order of halogenation or chlorination. What it means? If tertiary hydrogen is given, it is displaced first as compared to secondary hydrogen given displaces as compared to primary hydrogen given. Here tertiary carbon hydrogen, this is secondary carbon and this is primary carbon hydrogen. So first is greater than, second is greater than third. This is order of reactivity. So decreasing order of reactivity. Decreasing order of reactivity will be this, that is tertiary carbon hydrogen will be displaced first, then secondary will be displaced first, then primary. So this will be the order for chlorination of alkanes. Next, after chlorination, next is bromination. In halogenation, bromination, same as in the case of chlorination, CH4 with bromine in presence of H2SO4. Now elimination of HBr and formation of CH3Br with elimination of HBr, halogen bromide is obtained. Next is iodination. Iodination is some different type of halogenation reaction of alkane. It is reversible in nature. It is reversible. All are irreversible while this is reversible. CH4 reacts with iodine I2 in presence of HiO3 oxidizing agent, iodic acid. Now formation of Hi as byproduct with elimination with formation of CH3I. Since it is reversible in nature, reversible, what it means? In chemical equilibrium, the reversible reaction have characteristic properties of state of equilibrium when there is exactly equal molar concentration of reactant with product R. per second conversion of reactant into product and product into reactants under backward reaction becomes equal, the reversible reaction comes to the state of equilibrium where molar concentration of reactants and products becomes equal and rate of forward reaction becomes equal to rate of backward reaction. So here this HI formed reacts with iodic acid used as oxidizing agent under irreversible reaction, formation of I2 with H2O 3 3H2O 6 5HI. Here iodine is formed. This iodine formed in C2 used here in iodination of alkane, and from here this HI is removed from product side. At state of equilibrium, concentration of reactants and products is equal. If we remove one of the product, then molar concentration decreases in product side. So to equal this disturbance, rate of forward reaction increases up to the equal concentration in both the direction. That is, a concentration of reactants will be equal to the concentration of products, and again state of equilibrium will exist. So rate of forward reaction increases and more CH3I will be formed if HI will be removed from reaction, and this HI formed with react with HiO3 gives I2, I2 reacts with here with alkane and results CH3I. So since iodination of alkane is a reversible reaction, that's why oxidizing agent HiO3 is used. Next, flourination. Flourination of alkane. Flourination is not carried out by this method because it is violent reaction, exothermic, explosive reaction that along with carbon hydrogen bonds also breaks carbon bond. Along with carbon hydrogen bond breaks carbon bond. If methane reacts with fluorine violently under exothermic reaction C plus 4HF, this is obtained called carbon black. Carbon black is obtained or coke or soot. This is obtained when fluorine reacts with methane or any alkane. Since it is highly exothermic, explosive reaction violently reacts with alkane and gives carbon black or coke, because along with carbon hydrogen bonds, carbon bond also get break. That's why fluorination is not carried out by this method. Next is nitration of alkane. Nitration is carried out under high temperature like 500 degrees centigrade. So here nitric acid comes in vapor phase. That's why it is also called as vapor phase nitration of alkane. Nitration of alkane is a category of substitution reaction. And at very high temperature, approx 500 degrees centigrade, nitric acid comes in vapor phase. That's why also called as vapor phase nitration, and reaction is carried out under free radical mechanism. Like CH4 written in this way, nitric acid HNO3. This nitric acid can be written in this way, OHNO2, nitric acid under high temperature 500 degrees centigrade. Now elimination of H2O and formation of CH3NO2 plus H2O. Nitromethane is obtained. But if we take the alkanes of higher carbons, more in the case of alkane, in methane, one carbon is present, so more than one carbon is taken, then along with carbon hydrogen bond, carbon bond also get break. If we take ethane in place of methane, then here carbon bond is also present in the case of ethane. So since reaction is carried out under very high temperature, So nitric acid comes in vapor phase. It's also called vapor phase nitration. Is such a high temperature along with carbon hydrogen bond. Carbon carbon bond also get break. So along with substitution of hydrogen, alkyl nitro product also obtained like CH3 CH2NO2 after carbon hydrogen breaking, and after carbon carbon breaking CH3NO2. So a mixture of nitro compounds are obtained. As the number of carbon increases in alkane, the number of nitro product in mixture increases. It is due to along with breaking of carbon hydrogen bond, carbon carbon bond also get break, and order will be again like tertiary, greater than secondary, greater than primary. Next, after nitration, sulphonation. Sulphonation means reaction with sulfuric acid. Alkane reacts with sulfuric acid. H2SO4 can be written in this way: SO3, a mixture of H2SO4 plus SO3 sulfur trioxide is called fuming sulfuric acid. Fuming sulfuric acid, because here fumes of sulfur trioxide are obtained. Fuming sulfuric acid. So when alkane reacts with fuming sulfuric acid H2SO4 with SO3, elimination of H2O and this SO3H attached here are SO3H plus H2O. Alkane sulfonic acid like CH4 reacts with OHSO3H with SO3 fuming sulfuric acid, elimination of H2O and formation of CH3SO3H with H2O. The order of reactivity for alkanes will be the same because reaction is carried out through free radical mechanism. That's why tertiary greater than secondary greater than primary carbon hydrogen bond. So here if the CH3, CH2, CH3 is carried out sulphonation with SO3, that is fuming sulfuric acid, then for secondary, so CH3, CH, SO3H, CH3, and next primary CH3, CH2, CH2, SO3H with elimination of water. Means secondary and primary mixture of products will be obtained because tertiary greater than secondary greater than primary in the case of carbon hydrogen bond. Next is after sulfonation, next is isomerization. Isomerization in presence of anhydrous AlCl3. एनहाइड्रस AlCl3 एल्यूमिनियम ट्राइक्लोराइड की प्रेजेंस में एल्केन्स कन्वर्ट्स इनटू एल्केन्स. एल्केन्स में ही कन्वर्ट होगी. सेम नंबर ऑफ कार्बन का नंबर सेम होगा बट विल आइसोमेराइज एंड जनरली चेन आइसोमर्स आर फॉर्म्ड. इनमें चेन आइसोमर्स का फॉर्मेशन हो जाएगा. व्हाट आर चेन आइसोमर्स? व्हेन दे आर एनी ग्रुप विद इन एल्केन substituted change its position. A group or radical within a chain changes its position only and forms next chain, then chain isomers are formed. Next is isomerization. Isomerization in alkane. Since alkanes have no any functional group attached in it, that's why when there is branching in the chain, straight chain alkane without branching changes into branched alkane, then a number of carbons are equal in reactant and product form, then it's called chain isomerism. So alkanes undergo chain isomerism in presence of anhydrous AlCl3, and normal alkane means straight chain alkane without branching converts into branched alkane. ब्रांच एल्केन में कन्वर्ट हो जाएगी आइसो, नियो, एटसेट्रा लाइक CH3, CH2, CH2, CH3. This is normal butane, straight without branching. Under isomerization with AlCl3 anhydrous, it forms this isobutane. Isobutane is formed, it is branched. Here C4H10 general formula, C4H10 general formula, molecular formula is same but their chain is different. It is butane and this is 1, 2, 3, 2-methyl propane. This is 2-methyl propane. So students, isomerization is completed and chemical properties of alkanes are completed now. In next event we will continue after to it in alkenes and alkynes. Till then, thank you students.